I've started question 3 on the board here, although I've left some of it for us to do together. So our parent function was f of x equals x cubed. So the cubing graph looks like this, and I asked you to include 3 important points with x values of -1, 0, and 1. So we had to calculate -1 cubed is -1, 0 cubed is 0, and 1 cubed is 1. Now we're asked to sketch g of x, which is -1/2 x cubed plus 4. So I've created my table here, where if I were plugging in a number for x to evaluate it, the first thing I would do is cube the x value. That's just order of operations. I do parentheses. So order of operations, remember, is PEMDAS. I would do parentheses first. I don't see any parentheses. Then I would do exponents, so I would do the cubing. Then I multiply and divide, working left to right. One thing very important with order of operations, PEMDAS is a 4-letter word. It looks like it's a 6-letter word, but M and D are not separate operations. I don't multiply first and then divide. I do all the multiplication and division, just working left to right. Same thing for the A and the S, that's addition and subtraction. It's not that I add first and then subtract. I do all the addition and subtraction working left to right. So cubing would be the exponent, then I would multiply by the -1/2, and then I would add the 4. Okay. So this is the order in which I would evaluate them. Cubing, that's the parent function, so everything I do after that is going to affect the graph vertically. Multiplying by -1/2 actually does 2 things. It shrinks it by a factor of 1/2 and flips the graph vertically. Now, if you want to do that as 2 separate steps, you can. You can say multiplying by -1/2 is multiplying by -1 and by 1/2, and you can do those one at a time. I think it's simplest since it's just multiplying by a negative number to just do those at the same time. Okay. If you did them separately, it doesn't matter which you do first, the -1 or the 1/2. All right, and then adding 4, that's going to shift things up 4. So I'm going to just do this one step at a time. So I'm going to show the multiplying by a -1/2. So I'm keeping my x values the same, but the y value is going to get multiplied by -1/2. Whatever I'm doing here, I'm doing exactly that thing to my y values. So this point will have an x value of -1, but the y value will become +1/2. If I take the y value here, which is 0, multiplying that by anything, it's going to stay 0. So that point stays the same. And if I multiply the y value here by -1/2, it becomes -1/2. So I'm going to have a point 1, -1/2. All right, and I can see that did accomplish those 2 things. The graph is, it's a little hard to tell because it's still infinitely tall, but if I just look in here, between these 2 points, it's half the vertical distance that it was between these 2 points. And it's flipped over the horizontal axis, so it's flipped vertically. Now I'm going to shift things up 4. So that's just going to be accomplished by adding 4 to those y values. So at -1, keeping the x value the same, we were at 1/2, now we're going to be at 4.5. I can write that as either a mixed number 4.5 or as an improper fraction of 9/2. Here, keeping the x value the same at 1, adding 4 to -1/2 is going to take it up to 3.5 or 7/2. And, oh, I forgot to do this point. 0, 0, adding 4 to that y value is going to make that point be 0, 4. So that's going to be my graph here, and that's my final answer. Again, for showing work, I need to see that you did 2 things and the order in which you did that. I showed that 2 ways, one by actually writing down what I was doing and the order in which I was doing them, and then by actually doing them one at a time. You would need to do at least one of those things. Either do the transformations one at a time, or if you want to go straight from this graph to this graph, make sure you've written down the transformations you're doing and the order in which you're doing them. Now the next question, question 3, I had given you a graph rather than giving you a formula. So we had this point, -2, -1. We ended at a point 2, 1. And they were connected with this curve, like so. And we'd said that was f of x. And then we were asked to sketch g of x, where g of x was -3 times f of x plus 1. Okay, so I can do basically the same things here. I can create this table where I say, here's what I'm going to do to evaluate the function, and here's how that's going to transform the graph. Okay, so if I were plugging in a number for x, the first thing I would do is evaluate f of x, and that's my parent function. Then I would multiply by -3, and that does two things. That does a vertical flip because it's negative, and a stretch because the absolute value is 3, which is bigger than 1. And then I would add 1, and that's going to move things up 1. And because I'm doing these things after evaluating the parent function, that's what tells me they're vertical transformations. Okay, so I'm going to do them one at a time. So if I were to multiply by -3, I'm going to keep my x values the same, but the y values get multiplied by -3. So -1 times -3 is just going to be +3. So I'll have the point -2, 3. And then here the y value was 1. When I multiply that by -3, that's going to become -3. So I'll have a point 2, -3. All right, and they were connected with this curve, and I can see if I flip that curve upside down, which is what I was doing in addition to stretching it, I'm going to have something, flipping it is going to give it a shape that looks more like so. So I'm going to have a shape like so, connecting these points. Okay. All right, excellent. Then I wanted to move things up 1. So I'm just adding 1 to these y values. So that's going to become -2, 4. And this point will become 2, -2. And I'm connecting them with a curve that looks something like so. Okay. Now, this isn't exactly perfect because I didn't exactly monitor the points in between, but I found the really crucial starting and ending points and kept the curvature the right. If it was in this order, if it was going like so, then when I flip it upside down, it's going to be coming something like so, and I made sure to respect that as I drew those two graphs. I didn't connect these points coming like so, I came this way instead.